Hello everyone, this video will be on limiting reactant stoichiometry, or as I have decided to call it, extreme stoichiometry. And not because it's hard or anything, it's just because you may end up doing like 3 stoichiometry equations, which can get extremely tedious. But it's just like all the normal stoichiometry we've been doing, there's just more numbers that we need to worry about. So some vocabulary to get us started off. Limiting reactant. And the limiting reactant is going to be what runs out first. So when you are doing these equations, you'll have 2 reactant amounts. And the limiting reactant is going to be the one that stops the reaction from happening. It's going to give you the smaller answer. And that's the answer you're going to use because once you run out of this limiting reactant, the reaction stops. And so the other one would be impossible. So the one that gives you the excess, the one you have remaining is your excess because you have more of it than you needed. So the easiest way to do this is just to do an example. So let's say we have the equation P4O10 plus KOH gives us K3PO4 plus water. So the first thing you always have to do with stoichiometry is balance the equation. So we need a 12 here, a 4 here, and a 6 here. I think that gives us the right amount. Okay, so in this equation, it tells us we started with 5 grams of P4O10. We started with 10 grams of potassium hydroxide. And then the person who did this experiment ended up with 10.5 grams of potassium phosphate. So what we need to do is first we need to do 2 stoichiometry equations with each reactant to see what is our theoretical yield for this, because we want to find the percent yield. So we're going to start with this first reactant of phosphorus oxide. So that'd be 5 grams of P4O10 over 1. Get the molar mass of that, which is 283.88 grams of phosphorus oxide over 1 mole of it. So that's not 10, that's 5. Now we set up our molar ratio between this reactant and this product. So that would be 1 mole to 4 moles. And then we just need the molar mass of our product, which should be 12.27. And then that is going to give us 150 grams K3PO4. So don't box that answer because you still have another reactant to go through this process again. You need to do another stoichiometry equation to find out which, oh, that's not 50, that's 15. To find out which one is the limiting. So you're going to set this up again, but this time with the 10 grams of potassium hydroxide, which its molar mass is D6.11. And then we're going to set up our molar mass, which is 12 to 4. But since 12 and 4 can be reduced, like, in math, you always have to reduce your fractions. It's best to do that here so you have less to type in. This could be 1 and 3. And then this part of the equation is going to be the exact same from here. So we're going to have 2, 12.27. Since we're going to the same product, it's the same. 1 mole. So, and this will give us 12.6 grams. K3PO4. So, since the second reactant, this 10 grams of potassium hydroxide, gave us the smaller theoretical yield, this is actually the amount we want, because you always want the smaller one. Because this one is, now it's impossible, because once we run out of potassium hydroxide, it stops. So, and we know that it's the small, we know that potassium hydroxide is going to run out first because it produced the smaller answer. So if it asks which one is the limiting reactant is potassium hydroxide, and then the excess reactant is phosphorus oxide. Okay, so now that we have that, we need to find the percent yield, and the problem also asked for what amount did you use? How much potassium oxide was actually used in this equation. So that is going to require another stoichiometry equation, but you're going to go backwards this time. So you're going to start with the theoretical yield of the smaller one you found. So the one you've determined is the actual theoretical yield. And then you can just take that last part of the equation, just flip it, and then we're doing this to the excess yield because we want to find out how much was used. So that's 4 moles over 1 mole of phosphorus oxide. Come over here and then just put the molar mass of that on top. 10. And so that will give us 4.21 grams of potassium, or phosphorus oxide. Oh goodness. If the question asked how much is left over, we would take this amount and we would subtract it from the amount we started with. So that'd be 5.00 grams minus 4.21 grams. And then that would give you however many, what is it? 9, 8, 7, something like that. I don't have a calculator in front of me. But if it asks for how much is left over, that would be, assuming I did the math right, that would be the answer. Okay, so the last step of these are normally like super long problems. The last step is now we want the percent yield. So as we know, percent yield is just the actual yield over the theoretical yield times 100. And so the problem told us that The person who did this got 10.5 grams of K3PO4, and we know we got 12.6 grams. So we will put this in the calculator, round to the correct sig figs, and find out that it was 83.3%, which is not bad. Yeah. So for the excess problems, I forgot to mention. So you can start with the product and go backwards, or you could also start with the limiting reactant and work backwards. You'll get the same answer. I just know Ms. Mock likes to start from the product, so that's what I tend to do. But yeah, so that would be the most complicated problem you would have with limiting reactants. The key thing to remember is even if it says what's the maximum amount that could be created, you always want the smaller answer for these types of problems, because that reactant will tell you when it stops, if that makes some sort of sense. So I hoped this helped. Let me know if you have any questions or anything. And yeah, good luck on the test coming up. Thank you so much for watching.